The meaning of fluid dynamics is the study of fluid motion that involves forces of action and reaction. ठीक है? Or you can say the forces which causes acceleration or which resist acceleration. So that is fluid dynamics. So I repeat it. Fluid dynamics is the study of fluid motion that involves the forces of action and reaction. So in fluid dynamics, we have two basic equations. One is the Euler's equation, okay, and second one is the Bernoulli's equation. Okay. Now this equation is based on momentum principle, and this equation is based on energy principle. Okay. Now both these equations we derive from Newton's second law. Okay. Their derivation is based on Newton's second law. So that Newton's second law is sum of forces acting on any element should be equal to the inertia force mass into acceleration. Okay. This is Newton's second law. So with the help of this, we can derive Euler equation as well as Bernoulli's equation. Okay. So now I try to derive the first equation, Euler's equation. Now again in our syllabus for Euler equation, we have the general form as well as the Cartesian form. Okay. So in our syllabus, we have only two forms for this equation, general and the Cartesian form. Okay. So I try to derive now the general form of Euler's equation. Okay. That is general form of Euler's equation. So for this, I try to draw one diagram. Now say we have a pipe which is inclined at certain angle. Okay. Now in this pipe, this is the direction of flow. Okay. Now say okay, then this is the horizontal. This pipe is inclined at an angle theta to the horizontal. Now let us say for this pipe, the cross-sectional area is dA. Okay. The length of the pipe is say ds. Okay. So if we talk about its projections, so its vertical projection, that is along this line. This is dy, and the horizontal projection is dx. So this is something like this. This is dy, this is ds, angle is theta, and bottom dimension is dx. Okay. Now I see the various forces acting on fluid which is passing through this pipe. So for that fluid, this is the direction of flow. Okay. Now I try to write the forces. Now the first force acting on the fluid is the pressure force. The first force is the pressure force. Okay. Now say over here, the pressure intensity is P. On other face of this pipe, the pressure intensity is P plus dP. There is some difference from the bottom pressure. So that is say P plus dP. Then pressure forces at inlet is P into dA. So here the pressure force is P into dA, and here the pressure force is P plus dP into dA. Okay. So this is the first force acting on this element. Now the second force acting on this element is the weight of the fluid element. Now that weight acts through the CG in the downward direction. ठीक है? और weight क्या होगा? Weight is mass into m into g. Weight you can write as m into g, mass of fluid element into g. Now mass of fluid element is density multiplied by the volume. Okay. So density is rho. Volume of the fluid element is dA into ds.
Yes, sir.
Okay, into g, that is the weight acts in the downward direction. Now we can also resolve this weight into two part. Okay, weight into two part. One along the central axis, this one. Another is normal to it. Okay, so when we see here, this component is W sine theta, and this component is W cos theta. So here you can see this is same as W cos theta. This angle is theta. ठीक है, तो अब यहां से आपको क्या पता लगा कि वेट का कंपोनेंट जो है that is W sine theta in the direction opposite to that of flow. So this is W sine theta. So its direction is opposite to the direction of flow. ठीक है, तो वेट कंपोनेंट हमारे पास आ गया. The third force acting on this element is the resistance force or the viscous force. Okay, now viscous force is always acts in the direction opposite to the flow. Now say that force acts opposite to the direction of flow having magnitude dfs. Okay, so now you can write this dfs as, now this is the resistance force, so that we can write as tau into surface area. Now surface area for this cylindrical pipe becomes perimeter into length. So dp be its perimeter into its length ds, that becomes surface area. Okay, and tau over here is, the tau is frictional resistance force per unit surface area. Force per unit surface area. ठीक है, और विस्कस फोर्स पर यूनिट सरफेस एरिया. तो विस्कस फोर्स या फ्रिक्शनल फोर्स क्या हो जाएगी, टॉ multiplied by dp into ds. Now this tau depends on, or you can say we can find out the value of tau as from Newton's law of viscosity, mu du by dy. Okay, so that is tau over here. ठीक है, तो इतना का स्ट्रेस है multiplied by area, that give you the resistance force. ठीक है, so these are the various forces acting on this fluid element. Okay, now I apply here the second law, Newton's second law, that says the sum of forces acting on this element is equal to mass into acceleration. Okay, now I apply this Newton's law, Newton's second law, in the direction of flow. Okay, I apply this in the direction of flow, so that means the sum of forces in the direction of flow should be equal to the inertia force. Okay, so now I try to write the forces in the direction of flow. Okay, so in the direction of flow, if I try to write first the pressure force, here is PdA. So in the direction of flow, I write it as with positive sign. So PdA, then this force in the opposite direction, minus P plus dP into dA. Okay, plus body force. Now body force here is W sine theta. Now this is the direction opposite to the flow. So that means this force comes again with negative sign. Okay, so the force is with negative sign, and it comes out to be rho g dA ds sin theta. Okay, then the resistance force is this one, again opposite to the flow, minus tau dp into ds. Dp is capital P, that is perimeter, equal to the mass into acceleration. Mass of the element is rho dA into ds multiplied by acceleration, say that is as. Number one. Okay, now you can see here, now PdA cancels with PdA, so we left here with क्या बचेगा आपके पास, माइनस PdA, sorry, dPdA. It is minus dPdA. ठीक है, then minus, now you see this equation, this term now, Now the sine theta is, if you see this diagram, okay, sine theta is dy upon
upon ds.
ds. So ds ds से कैंसिल हो जाएगा, ठीक है, और जो रिमेनिंग टर्म अब आपके पास रहेगी, दैट टर्म इज माइनस रो जी dA
dA
into
dy.
dy. Okay, the third term minus tau dP into ds equal to rho into dA ds into as. ठीक है. Now I try to put here the value of acceleration. तो मैं acceleration पे concentrate करता हूँ. Acceleration क्या होगा? ठीक है. Now I say velocity. Now say velocity of flow in the direction of flow is u. I write it as u, velocity. U भी लिख सकते हो, कैपिटल V भी लिख सकते हो आप इसको. ठीक है. I write it as u. ठीक है. So I write u, that is a velocity, is a function of position and time. ठीक है. Velocity is a function of position and time. So I write the total derivative of u. That is as in the form of partial derivatives, curly u by curly s into ds, curly u by curly t into dt. Okay, so from this function, I can write the total derivative of u. Okay, now you divide all these terms by dt. So du by dt, divide by dt, divide by dt. Okay, so now see what is this term. This is acceleration. Du by dt is acceleration, so I write it as as. Okay, now ds by dt, that is velocity, I write it as u, curly u by curly s plus curly u by curly t. Now this is the value of acceleration. So the in acceleration we have two parts, one depending upon position and the second part depending upon the time. Okay. Now if I say, now here I put one assumption now, the flow is steady flow. तो जब steady flow हमारे पास होगा, that means any derivative with respect to time becomes zero. चाहे वो u है, चाहे वो s है, ठीक है, any derivative with respect to time, ठीक है, that becomes zero. Mass flow rate is constant. So there is no dependency on time in that flow. So that means for steady flow, this terms become zero. So in case of steady flow, now you can write acceleration as the component of position only. Okay. So when this part is a function of position only, okay, that is a function of position only. So you can also write this in the form of the partial derivative. We can write in the form of exact derivatives as du by ds. Okay, we can write it as du by ds. So I replace this as now by u du by ds. That is our acceleration with assumption the flow is steady flow. Okay. So now if I put here the term u du by ds, so ds जो है वो ds से cancel हो जाएगा. So now we'll have with minus dp dA minus rho g dA dy. I'm writing this equation. Okay. Minus tau dp into ds equal to rho dA into u du. Okay. Now in this equation, each term represents the force. Now in this equation, each term represents one force. ठीक है, ये प्रेशर फोर्स को रिप्रेजेंट कर रही है टर्म, ठीक है, ये बॉडी फोर्स या वेट को रिप्रेजेंट कर रही है, ठीक है, ये विस्कस फोर्स को रिप्रेजेंट कर रही है या फ्रिक्शनल फोर्स, ठीक है, और ये जो टर्म है ये रिप्रेजेंट कर रही है इनर्शिया फोर्स को. ठीक है. सो इन दिस इक्वेशन every term represents some force. So now I try to divide all these terms by mass of the element. Okay, the mass of the element is rho dA ds. It is rho dA ds, rho dA ds, rho dA ds, and rho dA ds. ठीक है, इस टर्म से हमने सबको डिवाइड कर देंगे। तो अब जो टर्म हमारे पास आएगी दैट रिप्रेजेंट फोर्स पर यूनिट मास। ठीक है, दैट वी कैन राइट एज फोर्स पर यूनिट मास। सो नाउ आई राइट दिस टर्म फर्स्ट। मैं पॉजिटिव फॉर्म में लिखूंगा इस इक्वेशन को, इसको मैं पहले लिखता हूं। सो व्हेन आई डिवाइड रो कैंसिल्स विद रो, डीए विद डीए, सो आई लेफ्ट विद यू du by ds।
ds
ठीक है, then I write the pressure force per unit mass, this term 1 and 2, ठीक है, and take it on the other side, it become positive, so this becomes plus 1 by rho, ठीक है, so da से cancel हो जाएगा, dp by
ds
ठीक है, then I write the body force, ठीक है, इसको भी मैं दूसरी साइड ले जाऊंगा इक्वालिटी साइन के, again it become plus, ठीक है, so rho cancels with rho, da with da, so I left with g
dy by ds
by ds, ठीक है, देन आई पुट इक्वल साइन, आई लेफ्ट दिस विद नेगेटिव साइन नाउ, ये जो फोर्स है, ठीक है, इक्वल टू माइनस टॉ बाय रो डीपी बाय डी। ठीक है, इसको इस साइड क्यों रखा, क्योंकि अगर मैं एक और एग्जांपशन पुट करूं, लेट अस से द फ्लो इज आइडियल वन, द फ्लूइड इज आइडियल वन, सो व्हेन फ्लूइड इज आइडियल वन, tau is zero because no viscosity, mu is zero, tau is zero, so this term becomes zero in case of ideal fluid। ठीक है, इसलिए मैंने इसको राइट हैंड साइड पे रखा है। ठीक, now this whole equation now is the general form of Euler's equation. This is the general form of Euler's equation. So in this, each term represents force per unit mass. Okay? Each term represents the force per unit mass, and this is the equation with only one assumption, that flow is
steady flow.
Okay? This is only with one assumption, the flow is steady flow. Okay? Now in this equation, the first term represents inertia force per unit mass. Okay? This term represents the pressure force per unit mass, inertia force per unit mass. This is the pressure force per unit mass, and this term is body
Weight
force,
per unit
weight
mass.
per unit mass, and this is the viscous or resistance force per unit mass। ठीक है, तो जैसे मैंने अभी आपको कहा कि अगर हम एक और assumption पुट कर दें, the fluid is ideal one, so tau becomes zero। ठीक है, और this equation now becomes u du by ds plus 1 by rho dp by ds plus g dy equal to 0 dy by ds, or in simple form you can write it as u du plus dp by rho plus g dy equal to 0। ठीक है, this is the one form। Now this is with two assumptions now। ठीक है, steady flow and the ideal fluid। ठीक है, we can also write it into another form। The first term we can write as 1 by 2 derivative of u square। Okay, the other terms are same, dp by rho plus g dy equal to 0। ठीक है, जब ये डेरिवेटिव आप ओपन करोगे, सो यू हैव 2 टाइम्स du। ठीक है, u डेरिवेटिव जब आप ओपन करोगे, इट बिकम्स 2u du, सो 2 जो है वो हाफ से कैंसिल होके यू अगेन हैव द सेम टर्म। ठीक है, सो दिस इज द जनरल फॉर्म ऑफ यूलर्स इक्वेशन।